Hey y'all. Today's lesson is the Pythagorean Theorem. Maybe you've heard of it, maybe you've never heard of it, but after today you'll know what the Pythagorean Theorem is and how to use it. So just some information. The Pythagorean Theorem is used only on right triangles. It's only for right triangles, so it has to have a 90-degree angle for you to use the Pythagorean Theorem. What the Pythagorean Theorem uses are the three sides. So these two short sides are called legs. If it's the two short sides, they're legs. If it's the longest side is always across from the right angle. Wherever the right angle is, that's going to be the longest side across from it, and that's this long word called the hypotenuse. The hypotenuse. I don't know where it came from. I'm sure we could look it up. What a strange word. But the longest side is called the hypotenuse. And the Pythagorean Theorem states that you will take a leg and square it. And you will add that to the other leg and square it. So if you take this leg and square it, and take this leg and square it, and if you add both those up, it will equal the third leg, the hypotenuse, squared. So that's what the Pythagorean Theorem states, that you square the legs. If you square both the legs and add them together, it's going to equal the third legs, or the third hypotenuse squared. And then here's the formula for the Pythagorean Theorem. A squared plus b squared equals c squared. So A and B correspond to the legs. So leg A and leg B. There's no real, doesn't matter which leg is A, which leg is B, but the legs are A and B, and then the hypotenuse is always C. Now that one has to be, the hypotenuse is always C. So when you're doing problems, the hypotenuse has to be C, and the legs can be A and B. So this is a little bit about the Pythagorean Theorem. Only on right triangles, and you're going to square the leg plus the squared of the other leg is going to equal the hypotenuse squared. Okay. Example 1. All right. Find the missing length. Find the missing length. All right, you see my right triangle, and we have a leg, and we're missing the hypotenuse. So in order to find the missing leg, or the missing hypotenuse, we're going to start with the Pythagorean Theorem. I'm always going to tell you to start with the Pythagorean Theorem. Now we're going to substitute in. My legs are 45 and 28. It doesn't matter which one I put in for A and B. So I'm just going to start with 45 squared. So that is being substituted in for A, plus 28 squared. And that's going to equal C squared. I don't know what C is yet, so I'm just going to bring C squared down. So now we're actually going to square these. Do not try and multiply 45 times 45. Just square it in your calculator. It's 2,025 plus 28 squared is 784, and that's going to equal C squared. We have to add those together, and I get 2,809 equals C squared. And then recently, you just learned how do you undo the square function. To undo a square function, we have to take the square root. So once we get here, we're left with C squared. We don't want C squared, we want C. So we need to take the square root of both sides. Once you take the square root of C squared is C. And then I can take the square root of 2,809, and my answer is 53. So 53 centimeters would be my answer. Okay? And if you want to, do 53 squared, and you should get 2,809. But this is an example of a missing hypotenuse. Now, example B, we have the hypotenuse. See, it's across from the right angle. We have a leg, but we're missing over here a leg. So if you're missing a leg, it doesn't matter if you put A or B. It's up to you. I particularly like to start with if a leg is missing, I like to start with A squared. And then I like to put this in for B. That's just what I like to do. A squared plus B squared equals C squared. Sorry. and then 16 is my C. So I've substituted my numbers in. Now I'm going to continue solve. I don't know A squared, so I bring that down. 8 squared is 64. 16 squared is 256, I think. Let me just double check. When in doubt, type it out. Yep, 256. And this time I need to subtract 64 because I have an equation. A squared equals minus 64 to 192 maybe. But I have A squared. I don't want A squared. I want A. So I'm going to take the square root of both sides. And the square root of 192 is 13.856. So 13.86 meters. So I'm just rounding to the nearest hundredth. Hopefully you'll have directions that will tell you to round to the nearest tenth or hundredth, but that's just what I'm doing. All right, so let's do example C together. Again, let's start with the Pythagorean Theorem. A squared plus B squared equals C squared. In example C, I gave you A, and A was the square root of 6. So it's going to kind of seem weird, but you're going to substitute in the square root of 6 squared. Plus B, we don't know, so we're going to bring over B squared. C is the square root of 15, so when you substitute it in, it becomes the square root of 15 squared. Now, the funny thing is for this one, you can type this into your calculator, but if you type in the square root of 6 squared, the square root and the square cancel each other out. Same thing here. So I'm left with 6 plus B squared equals 15. I need to subtract 6 from both sides, so B squared equals 9. And then I can take the square root mentally because I know the square root of 9. So in this example, B equals 3. B equals 3 because the square root of 9 is 3. Okay? So even if you have like strange, weird looking square root numbers, you still plug them into the Pythagorean Theorem and you do everything the same way. Okay? So, I know that was quick, but let's talk about the converse of the Pythagorean Theorem. Feels so far away. The converse of the Pythagorean Theorem is just it backwards. It basically says if A squared plus B squared equals C squared, then you have a right triangle. It's kind of like we're seeing if the numbers fit to find out if the triangle is a right triangle or not. So in these examples, I'm going to show you what to do. Do these measurements form a right triangle? You have 50, 64, and 80. If you just saw those three measurements on a triangle, but you didn't know any of the degree measurements, you could test it to see if it really would form a right triangle. Here's how you test it. You are going to plug them into the Pythagorean Theorem. My longest side has to be C. The longest side has to be C. 50 squared plus 64 squared equals 80 squared. And instead of writing the equals, we'll just write a question mark because that's what we're trying to find out. 50 squared is 2,500. And 64 squared is 4,096. 80 squared is 6,400. So we need to add these two up to see if it's going to equal 6,400. But I can already see right now, when we add these two, I'm going to have something that equals 96. I'm going to add them up just to see. 65, 96. So they do not equal. So this is not a right triangle. It is not a right triangle. Or you can put RT triangle. This is not a right triangle because these values do not satisfy the Pythagorean Theorem. It might be a triangle, but it's not a right triangle. So let's do B. Did the lengths 15, 25, and 20 form a right triangle? Again, find your longest side, which is 25, so that's our C. And we're going to plug them in. 15 squared plus 20 squared. Does that equal 25 squared? 15 squared is 225. And that, I guess, is 400. And then 25 squared, I think, is 625. Let's just make sure. 25 squared is 625, yes. So 225 plus 400, I know, is 625. 625 equals 625, so the answer is yes. This is a right triangle. Because my values fit into the Pythagorean theorem, this has to be a right triangle. You try C. Pause it. You try C, and then press play when you're ready to see the answer. Okay. 10 squared plus 12 squared, question mark, 16 squared. 100 plus 144, and this is 256. And then I can already tell 100 plus 144 is going to be 244, not 256. So the answer is not a right triangle. All right, this is not a right triangle because they do not fit into the Pythagorean theorem. Okay. All right, so Pythagorean triples. Pythagorean triples are a set of 3 integers. A set of 3 integers, A, B, and C, because we've been talking about A, B, and C. A set of 3 integers, A, B, and C, so that A squared plus B squared equals C squared. And what that means is that if you had 3 integers are whole numbers, but we're talking about positive integers, so that it satisfies the Pythagorean theorem and they are no decimals. Earlier we did an example that came out with a decimal. That's not considered a Pythagorean triple because it had a decimal. So these are 3 integers that satisfy the Pythagorean theorem. Some examples. For an example, a very common Pythagorean triple is 3, 4, 5. That's not the only one, but that's a very common one. So if you saw a triangle that said 3 and 4, then you would know the other side has to be 5. Or if you had 5 and 4, then you would know it has to be 3. If 3, 4, and 5, all the multiples of 3, 4, and 5, like 6, 8, and 10, 30, 40, 50, 300, 400, 500. Or you can multiply them all by 5, and you would get 15, 20, 25. Those are all considered Pythagorean triples. It's just kind of ones you know really quickly. Another example of Pythagorean triple would be 5, 12, 13. So if you saw a triangle and it had 5 and 12, then you would know, oh, that has to be 13. Less common than 3, 4, 5, but still is a good one. Another one that you might see would be 8, 15, 17. I'm not saying you have to have these memorized. You definitely would want to know 3, 4, and 5 and any multiples of 3, 4, and 5 because that will save you a lot of time. If you were to come across a triangle and you saw 5 here and 4 here, then you would know, well, this has to be 3 because it's a Pythagorean triple. All right, so I'm going to show you a few examples of Pythagorean triples. Okay. Determine if the given lengths could be considered a Pythagorean triple. Again, we're going to test these out to see if they fit into the Pythagorean theorem. We'll start with A. This is our C because it's the longest side. So 6 squared plus 24 squared, does that equal 25 squared? 24 squared, I don't remember what 24 squared is. 576. And this was 625. So 36 plus 576. I don't think those are going to add. Whoops. 576 plus 36. All right, 612 does not equal 625, so the answer is no. These cannot be a Pythagorean triple. Let's look at B, 21, 28, and 35. So 21 squared plus 28 squared and 35 squared. Do those equal each other? Now, I can type all this into my calculator and see that they are going to equal each other, but one thing I want you to notice and recognize is this is a multiple of 3, 4, 5. 3, 4, 5. Can you figure out what was the scale factor used, multiplied The factor used multiplied was 7. 3 times 7, 4 times 7, 5 times 7. And if you can recognize that, then you know that the answer is yes. This is a Pythagorean triple. You can type in your calculator and check, which I encourage you to do, but I know that it's 3 times 7, 4 times 7, and 5 times 7, which makes it a Pythagorean triple. All right, you try C, pause it, and you try C. Okay, 18 squared plus 80 squared. So 90 squared is going to be 8100, 6400. I don't remember 18 squared. Oops, I turned it off. 18 squared. Oh man, my battery's just died. 18 squared, I don't know, but whatever it is, I guess I can multiply it out, but this video is long enough. Oh, I'm having trouble. 18 times 18, 324. So if I add 324 to 6400, it's going to be over 8100. So the answer is nope. This is not a Pythagorean triple. Okay, so hopefully at the end of this, you know what the Pythagorean theorem is and you know how to work problems, and we will practice more in class.